Yeah, you all go to your Google Classroom already? Some of you haven't accept. Later I tell you who you are. So when you go to Google Classroom, that's where I will put up the video, then a bit of summary of what we did, all this. Okay, so let's continue with question 2. Solve. When you see this word solve, that means you have an equation and then you want to find out what is x. What is the value of x that will balance this equation, that will make the left side equals to the right hand side? That is the meaning, solve. What is this value? You want to finally know, oh, this value should be what? Okay, so if I give you a very simple example, if you are asked to solve for this, just by looking, I don't need to do anything. I want to solve this equation. I want to know what is x. X must be 3. Because 2 times 3 will give me 6, which is the same as the right. So solving is just like that. I want to find out what is this value that will make balance, that will make both the same. Okay? Just that when the equation gets more and more complicated, we cannot straight away tell. This one is I straight away can tell 2 times 3 must be 6 ma. So I can say the solution of this equation is x equals to 6. The answer is x is 6. That is the meaning of solving equation. Hey, sorry, x is 3. Very good, very sharp. I testing you. Okay, can? That's why in between we need to do a lot of logical thinking. As long as you are logical, you can solve equation. So same one. When you are asked to solve this equation, your final answer or your finally what you want is definitely what is x. X is what? So no matter what kind of equation you are given, as long as you are asked to solve, this is your final step. Then how do we get from here to here? That is the question. Correct? So slowly, I have negative 1 and 1/4. It is very difficult to work with a mixed number in mathematics 1. So for my first step, I will change my mixed number to a improper fraction, or where the numerator bigger than the denominator one. Okay? So when I want to solve equation, my job is actually to continue to write equations. I must continue to write equations. Primary school is answer equals to something. You usually answer then equals to something, or continue to equal to something. It is always one direction. But actually that is just one way of using equal sign. The main thing of equal sign is equal means left is the same as right. It is not this direction only. We are always writing another equation, make the left still equals to the right. So now x over 8 is still x over 8, no change. So this is my left hand side. Then my right hand side, negative 1 and 1/4 can also be written as every 1 here is 4 over 4. So it is actually 4 over 4 plus another 1 over 4. 1 and 1/4 ma. So it is actually 1 and 1/4. So when you add this together, your 1 is a 4 at the numerator. That's why it will become 5 over 4. Then the whole thing is negative. So I have a negative 5 over 4. Okay? Then another thing, negative of this fraction can be negative 5 over 4. It is the same as, I can put the negative on top. Negative 5 divided by a positive 4. The result will be a negative 5 over 4. Or 5 divided by a negative 4, I will also get back negative of 5 over 4. So whenever you have a negative fraction, actually you can put the negative on top, you can put the negative below. Both okay, both are the same. These three are all the same. It is just different way of writing the same thing. Then, according to situation, sometimes put on top better, sometimes put below better. It is the negative of the entire numerator or the negative of the entire denominator. But it cannot be negative 5 over negative 4. Because if you have negative 5 divided by negative 4, negative cancel, it will change back to positive. So this one is not correct. So when you have a negative, it can be on top, it can be bottom. Can? Yeah. Okay, next step. If you compare, now I have x over 8. In the end, I want x. Okay, definitely I want x. So if I just look at, I cover, it will still show, right? If I only look at my left hand side, I focus on my left hand side. From x over 8, wishful thinking, how can I make it become x? Times 8, right? Because x over 8, if I don't care, totally don't care this side, I just care about how I can reach my destination. I want to multiply by 8. Because if I multiply x over 8 by 8, 8 is 8 over 1. Then cancel, my 8 will disappear. Then, yay, I'm left with x. Cancel away. Okay? Then, we are writing equation. So whatever I write, left same as right. I want to write the next line, left still same as right. But if I want to multiply something to the left here, and I don't do anything to the right, then they will be different already. That is why when I multiply by 8, I must do the exact same thing to the right. So in an equation, you will find that actually it's very convenient one. As long as I do the same thing to both sides, they will still be the same. Because they are the same. Then if I do the same thing to them, they will still result the same. Okay? Then it will, so my 8, I purposely choose 8 to cancel this, then it will become x only. Then this side, I will have negative 5 over 4 times 8. When you practice enough, you will find that this 8, when it crosses the equal sign to here, actually it is from divide 8 become multiply 8. The 8 disappear from the left already. The 8 appear here. From denominator, it come over to the numerator already. Then it is the same for plus and minus. My plus, if I have plus something here, it cross over here, it will become minus something. It is by the same idea. Later we will see. So this one is just, I multiply 8 to both sides. Then I get my left hand side already. Then I just need to simplify this number. Then I have my final answer. So negative 5 over 4 times 8. 4 divided by 4 is 1. 8 divided by 4 is 2. Cancel. So I'm left with the final answer. Negative 5 over 1 times 2. Negative 10. Or another way, if you can reach this step, negative 5 over 4 times 8, you can key this into your calculator already. Negative 5 over 4 times 8, your calculator will tell you minus 10. So solving equation is just like that. No matter what equation, you want to do steps until it looks like x equals to something. Then you can solve already. Okay? And if we go back, what is this negative 10? This negative 10 is actually something that, if I put it here, negative 10 divided by 8, you key inside calculator, it will result in negative 1 and 1/4. We are just finding what is the x that will make this the same. This is the whole idea of solving equations. Finding what is this value that makes left and right the same. Follow so far?
Yes.
Wow, very good. Okay, then go to part B. The whole idea is exactly the same. I am asked to solve an equation. I am given this equation, look a bit more complicated, but no matter what equation, I already know my endpoint. My endpoint is x on one side, and then I put all the numbers on the other side. So in between, yes, there will be a lot of steps, but I already know all these steps is to make x on one side, numbers on one side. Can? Okay, then it goes back to yesterday we touched a bit on fractions. I have this fraction, I have this fraction. The numerator got two terms. The numerator got 2x, got minus 3. The numerator got x, got plus 3. Then yesterday I told you all, when the numerator got more than one thing, we must put a bracket to remind ourselves they belong together. Together they form the numerator. Okay? That is. From there, then again we go back a bit like part A. I don't want fraction. In the end, I only have x. The equation is we don't want to work with fraction 1. Okay? But my x got 2, is over at 2 place. So finally I want to put them together. Then right now they are inside the bracket. I cannot work with them yet. I want to remove the fraction first. So if I just look at the left, what do I need to do? Multiply 2, right? Okay? So I need to multiply 2. Because multiply 2 will cancel away this. But because I multiply 2 on the left, I need to multiply 2 on the right. Okay? So this times 2 and times 2 is because of this. Then when I look at the right hand side, I also have a fraction. I also don't want this 5. So to remove this 5, I need to times 5. And this side I also must times 5. Because anything I do on one side, I must do on the other side. So that they are still equal. When I write the next line, they are still equal. Okay? Then it will result in something. My 2 will cancel away with this 2. Another color. My 2 will cancel away with this 2. And the 5 that I choose will cancel with this 5. Okay? Then I no longer have fraction already. After this question, can? Okay? Then I no longer have fraction because the 2 cancel away, the 5 cancel away. What I'm left with? 5 multiply the entire bracket. On my left. And my right is left with 2 multiply the entire bracket. A lot of teachers, tuition teachers, they teach the students to see this as cross multiply. The denominator multiply the numerator, then the denominator multiply by the numerator to help them remember. Then become this numerator times this denominator. Then appear here. Then this numerator times this denominator appear here. But I would rather you all don't just remember the term cross multiply. You all know why it comes about. Cross multiply is the result. If you know why, then every time you can also own self come up with this. Can? But if you already remember cross multiply, then you must know when to use it. It is only when a fraction equals to a fraction. only, then you cross multiply. There will be other instances where you cannot cross multiply one. Okay? Okay, then when it comes to like that, one thing is, mathematicians are clever and lazy. So whenever we see this, we must know that this one actually means 5 multiply bracket. This one actually means 2 multiply bracket. Mathematicians, because every time it is multiply, so they don't no longer write the multiply already. So we own self must know this is actually 5 times bracket. It came from 5 times bracket. So when we are multiplying this bracket, same like what I mentioned yesterday, there are 5 times of this bracket, means there are 5 times of everything inside. Inside got 2x, inside got minus 3. So when I do my expansion, or when I open up the bracket, there are 5 of 2x. 5 times 2x, 10x. There are 5 times of negative 3. 5 times negative 3, negative 15. 2 times of this bracket, so 2 times of x, 2x. Same. All this 10x, 2x is actually means 2 times x, 10 times x. Mathematicians lazy, don't write the multiply one. Then 2 times positive 3. 2 times 3, 6. Now that we have freed the x from the bracket, it is another step closer to what I want. I want all the x on one side, I want all the numbers on one side. So this 10x is already on the left, so good. I don't need to touch it. But this x is on the right hand side. I don't want any x on the right hand side, I want all the x on the left. So I want to remove this 2x. If I only look at the right hand side, got 2x, I don't want 2x, that's why I minus away 2x from the right. 2x minus 2x will cancel each other, become 0. So when I minus 2x on the right, I am writing equation . So if I do something to the right, I must do the same thing on the left. Okay? So that is why it will appear like my positive 2x, a plus 2x, cross the equation, cross the equal sign, become a minus 2x here. 2x cross become minus 2x because actually I am subtracting it on both sides. Then same, I want to put all the numbers here. So my 6 is already on the right, I don't need to touch it. But my minus 15, this is a number, it is now on the left. I don't want numbers on my left, I only want x on my left. So I want it to disappear. Minus 15, how I can make it disappear? Minus 15 plus 15. But because I plus 15 on the left, I plus 15 on the right. So it looks like my minus 15 cross the equal sign become plus 15. Can? 10 chicken wing, take away 2 chicken wing, left with 8 chicken wing. 6 plus 15, 21. Okay? I want x, I don't want 8x. From 8x become x, I need to, yes, very good. And because I want to divide by 8 on one side, I need to divide by 8 on the other side. Okay? So again, it looks like my 8 cross the equal sign. From numerator, it was multiplied, then it become divide by 8. Then this is my answer. Okay, don't put in decimal. Fraction is more accurate than decimal. Oh, okay lor. But in general, there is no need to write in decimal. Just give in fraction. Okay? Okay, go. Follow so far? Yes. Turn up, turn down. Turn up, too cold. Off the fan. Okay, off the fan already. Okay, go. Can? Okay, question 3, inequality. So like what I said just now, solving inequality is actually almost exactly the same as solving equation. I want to finally reach x and then the numbers here. I don't know whether it will be bigger or smaller. That one later. But I know I want to put all my x on one side. I want to put all my number on one side. Okay? I want to put all my unknown on one side. I want to put all the numbers on the other side. So, if I look at my original inequality, I have x at the left hand side, I have x on the right hand side. So I don't want this x here. I want it to be at the left hand side, which is why I continue to write the next inequality. Just like equation, write the next equation. Inequality, I write the next inequality. My x here, I don't need to touch. But this 3x, I want it to be here. I want it to be here, I need to minus away 3x from the right. As I minus away the 3x from the right, it will appear on the left also. Then this number, I don't want it to be on the left. I want it to go to the right. So, don't change sign because I'm just adding and subtracting. So I don't need to change sign. My negative 9 was here, so it is still here, right hand side. My minus 3, I want it to come over here, that's why I plus 3 and plus 3 at the same time. So it appears here as plus 3. Okay? Then in mathematics, every line we try to can simplify, we simplify. X minus 3x, negative 2x. It is a bit like positive and negative. I go one step to the right because this is positive, plus x. Then I move 3 steps back because this is negative. So end up, if I begin here 0, this is 1. I plus 1, minus 3, it will be left with here. Minus 1, minus 2. Plus and minus, they are opposite direction. That's why x minus 3x become negative 2x. The negative more powerful, moving back here. Then the x here is cancelled, just cancel one of them only. So left with negative 2x. Plus and minus is like a direction like that. Can? Then this one simplify. Negative 9. I go back 9 steps. I come back 3 steps. So still have negative 6. Then from negative 2x to become x, I need to divide by negative 2 so that it will cancel away. Then I must do the same thing, negative 2. So this number I get already, it is going to be positive 3. Okay, but going by the reasoning just now, whenever we multiply or divide a negative, your number change sign, then your direction of the inequality will change. That is why at first is negative 2x smaller than negative 6, but when I divide by negative 2, my next step, this one will change sign already. From smaller than, it will become larger than. Okay? Another way to look at solving this inequality from this step. There is one way that you don't need to change the direction one. Negative 2x smaller than negative 6, right? When we are adding and subtracting, the signs will never change. So, another way to solve this, negative 2x, I don't solve by dividing. I plus 2x here on the left. This one will cancel away. Then I plus 2x here also. So instead of putting my x on the left, I put my x on the right. Then I will have plus 2x. Then I plus 6 to move this across. Plus 6. This one disappear from the right, appear on the left. 2x larger than 6. Then divide both sides by 2. Then because it's a positive number, I don't need to change sign. So I will get the same answer actually. X larger than 3. This one I never change the sign at all. Just by using plus and minus. Okay? This is just to show you why it will change sign, because of the negative. X should be larger than 3. X should be larger than 3. Tahu? Okay. Then it is very common, even in the N level, they will continue to ask this question. After inequality, they ask you to show it on a number line. So number line, like I mentioned, going right is becoming bigger and bigger. So everything towards here, 2, 3, 4, 5, it can continue. 6, 7, 8, 9, 10. If I go there, it will become 0, negative 1, negative 2, negative 3. So what is the solution of A? Then how can I show it here? The solution of A is, I want a number, this x. This x must be a number that is larger than 3. Okay? So if 3 is here, should the answer be to the right or to the left? Right. Because this side is larger than 3. So I want all these numbers. How I show people I want all these numbers? I draw one line like that. Then I put an arrow. I want everything that are here. 3, 4, 5, 6, 7, 8, 9, 10. Yes. Huh? Circle. I will come to it. Okay? So what I want is all these numbers. 4, 5, 6, 3.5, 3.75, all these. Every number here. That's why one line with an arrow will tell people, I want all these things that are larger than 3. Then at the starting point here, this one is the difference between, do I put a solid dot or put an empty dot? Huh? Sorry? Okay. Then whether I use this dot or this dot will depend on this sign. This means x larger than 3. Yeah. Sorry, got one extra line here just now. I used to write something used to show something. So it is x larger than 3. When you only see one line like that, larger than, it means strictly larger than. It can be 3.0002, but it cannot be 3. Because I want something that is larger than. I want 3.1, I want 3.3, I want 4, I want 5. I want 3.00009, but I don't want 3. Because 3 is not larger than 3. So I strictly only want larger than 3. So if I only strictly want larger, that means, is this dot part of my answer? No, right? Because if this is, I want this point, this point is 3, that means 3 not larger than 3, then wrong already. So how do I signify that I don't want this point? Empty one, no? Solid one means it is there. Empty one means it is not there. That's why the answer is like that. Empty dot. Empty dot to show that although I start at 3, but I don't want 3 itself. It's empty here. This empty is to show that you don't want 3. A solid dot would means it includes 3. So funny, eh? Oh, you say wrong answer. Never mind. We will always make mistakes. Then we learn from our mistakes. If you know everything, you don't need to come to me already. You don't need to come to lesson already. Okay? Yeah. So don't know is correct one. Don't know but you learn. Then you become better. Can? Okay? So empty dot means you don't want. Solid dot means you want that dot. You want that point. Okay. Data bar chart. First, when we see a chart like this, we will go and look at what is the x-axis, what is the y-axis. Meaning, what is on this line, what is along this line. So they will tell us along the left, along the left and right, is telling us number of children. So if I read this number, this means no children. Here 1 children, here 2 children, here 3 children, here 4 children. Then as it goes higher and higher, the up and down tell me the higher is the more family. Like that got 10 family. Here got 20 family. So if I read this as a whole, then this chart, that means 0 children. Then how many family? 0 children? Here. Each small box, 10 small box is 10. So like that is 8 small box. Meaning I have 8 family with 0 children. Then I read here 10, 11, 12, 13, 14, 15. 15 family got 1 children. Here just nice at 20. 20 family got 2 children. 12. Because 10, 11, 12. Every small box is 1. So 12 family got 3 children. Then here 1, 2, 3, 4, 5. 5 family got 4 children. So this chart itself, by itself is telling me already. 8 family got 0 children, 15 family got 1 children. Okay? So this is what the chart is telling me. This is the data that they are giving me. Okay? Then we go and read the question. How many family have exactly 2 children? Okay. Then we go and read 2 children, 20 family. Answer 20. Easy? Easy, right? How many families are there all together? So we add up. 8 family like that, 15 family like that, 20 family like that, 12 family like that, 5 family like that. So the total family is this plus this plus this plus this plus this. Then it gives us the total family already. Can? So if you understand the chart, you understand the question, the mathematics is quite straightforward lah. Just additions only here. Plus 12 plus 5 equals to 60. 60 families inside this survey. Wow, how many children? Then this one is more tedious a bit. But if you know, you understand the chart already, then they ask you how many children are there all together. 8 family, 0 children. 8 times 0, still 0. 15 family with 1 children means out of the 15 family, 15, each of them got 1 children. So 15 times 1. Sorry, each of them got 1 child. Child is singular, children is plural. So 15 times 1 plus 20 times 2 plus 12 times 3 plus 5 times 4. When you add up all this, that will be the total number of children. Follow so far? If you understand, then the mathematics actually not that difficult. 60, 75, 105, 111. Okay? Ugh. Okay. Okay, this one I think the question got a bit of problem. The problem is too easy and give too many marks. Find the value of x. So you are given a pie chart. Pie chart, we are measuring the angle. How big is each piece of the pie? Then the angle is how much it rotates. Okay, so like that, from like that, rotate this much is 110 degree. Then they tell you this x, rotate this amount is 90 degree. So they tell you this is 90 degree already. Then they ask you what is x. So x is 90 lor. Oh yeah. Yeah. So this question actually got problem. Sorry. Shouldn't take this question. Anyway, this is put there to distract you. Okay, sorry, this question got problem. So just look at there. They actually just want you to say x is 90 degree or x is 90. Yeah, that's why I tell you this question got problem. Found 2x. Okay, never mind. Keep to this. X is 90. Yeah. This question is set wrongly. Yeah. This question actually set wrongly one. So the more important one is the part B. Part B. 110 degree of people like Milo. Okay? From this chart itself, we should be reading the chart out of 360 degree, 110 degree people like Milo. Then they also tell us in part B, 22 students like Milo, meaning here is 20. 20 or 22? 22. Here is 22 people. Then they ask you in total how many people. So it is actually like asking you to compare. This 110 degree is 22 people. Then what is the entire 360 degree is how many people? So the question is actually asking you this. Okay? They tell you already, like that is 22 people. So like that is how many people? That is the question that they are asking. Okay? Then it is just a proportion. 110 degree is 22. Then how much is 360 degree? You can find 1 degree first. So how do I find 1? Okay, I need more space. I write here. Okay. I want to find 360 degree. Proportion. Every 110 degree is 22. Then I want to find 360 degree. From here to here, a bit difficult to jump from here to here. So whenever got proportion question, it is easier. I find a midpoint. First, I find how much is 1 degree. Then, it works a bit like your equation. From 110 become 1, I need to divide by 110. Then I can find 1 degree. So this side, I will do the same thing. Divide by 110. Divide by 110. 22 divided by 110. Then from 1 degree to 360, a bit easier. I just multiply 360. Then I do the same thing here. I also multiply 360. So 360 degree, I will have like that. Then I can press calculator. Equals to how many? Yay! Thank you. So all together 72 students. Okay? Can? So the mathematics or the calculation part usually is not that difficult. If you read and understand the question, then you can come up with the calculation part.